today we will study the factors influencing the enzyme catalyzed reaction. This is a very important question for your final exams. So you should know all the factors point by point to the factors which affect the enzyme catalyzed reaction. So we have 8 factors which affect the enzyme catalyzed reaction. We will see each and every factor one by one along with their diagrams. So first factor is the effect of substrate concentration. Substrate concentration, as we have earlier seen in the previous video, we have seen that enzyme when reacts with the substrate, it forms a enzyme substrate complex and then the product is formed. So as we can very well see from this reaction that as we increase the substrate, initially the definitely rate of reaction will increase and it will reach to a point where we have got a Vmax upon 2. We will draw a plot in which one side will take as the concentration of substrate and another side will be the rate of reaction. Then we reach a point which is showing you Vmax upon 2. Actually it is the concentration of substrate required to half saturate the enzyme. That means this is the concentration of the substrate and this much is the Vmax upon 2. This much is the concentration required to half saturate the enzyme. That means after this, all the enzyme active sites of the enzymes are fully saturated with the substrate. So now, as soon as we will increase the substrate concentration after Vmax, then there will be no effect on the rate of reaction because all the active sites of enzymes are saturated with the substrate. So then we get a saturation curve, which is called as hyperbolic curve. It takes the shape of a hyperbolic and it is also called as saturation plot because at one time, that is at Vmax, where the velocity is maximum, the substrate concentration will not affect the rate of reaction because all the active sites of enzymes are fully saturated with the substrate. To understand the effect of substrate concentration on the rate of reaction, we have a Michaelis-Menten equation in which V is the velocity of enzyme catalyzed reaction, Vmax is the maximum velocity, that means after which no saturation will affect the rate of reaction. And this is S is the substrate concentration, Km is the Michaelis-Menten constant which is equal to the Vmax upon 2. Now I have earlier told you is the Vmax upon 2 is the concentration of substrate required to half saturate the enzyme. That means after it attains a Vmax velocity, all the active sites of enzymes are fully saturated with the substrate and then there will be no change in the rate of reaction. So the plot takes a hyperbolic curve, that's why it is called as hyperbolic curve or saturation plot. That means after Vmax it is saturated. The active site of enzyme is fully saturated with the substrate. So for that we have a Michaelis-Menten equation and this Km is the Michaelis-Menten constant. Now second factor that affects the enzyme reaction is the enzyme concentration. So for that we have this graph which is showing the enzyme concentration and the rate of reaction. Here it is following a linear plot. That means as we increase the concentration of enzyme, the rate of reaction will automatically increase. Then the third factor is effect of pH. Now we very well know the pepsin which is the enzyme involved in digestion. It works at the specific pH around 1.2, or we call it as acidic pH. So we can say that some enzymes act at particular specific pH. But if we talk in general, then we can say that the optimum pH for the maximum activity of enzyme is around 6 to 8. Right? We have some enzymes which act on the acidic pH also. We have some enzymes which act in the alkaline pH range also. But mostly enzymes act in this pH range, around 6 to 8. That's why we have termed it as optimum pH. That means we have the maximum activity at this pH range. The next factor is the effect of temperature. So similarly, as we increase the temperature, the rate of reaction will increase. But there is some optimum temperature range. That means after this temperature, the rate of reaction will decrease due to denaturation. The enzyme gets denaturated. It becomes inactive because the structure of enzyme breaks down. So this is the optimum temperature where the enzyme is showing the maximum activity, which is at 37 degree. But enzyme can work in the optimum temperature range. That means from 37 degree centigrade to 45 degree centigrade. But after 50 degree centigrade, the enzyme gets denatured. It becomes inactive. Now coming to the next factor, that is effect of coenzymes. We very well know, we have earlier seen in the video that all coenzymes, they increase the rate of reaction because they form the active form of the enzyme, which is holoenzyme. Then next factor is effect of radiations. Radiations are always harmful. They will decrease the rate of reaction. Then oxidizing agents, how they will decrease the reaction? They will form peroxides. They will cause the oxidation of the enzyme by forming the peroxides, and thus they will also decrease the rate of reaction. And the last point is inhibitors. The name itself it is indicating that they will inhibit the enzyme activity, or they will inhibit the rate of enzyme catalyzed reaction. So one thing I just wanted to tell you, that how the enzymes act, or how the progress of reaction takes place when there is an enzyme catalyzed reaction or when there is no enzyme. So we can very well see from this graph that this is the activation energy. You can see in this graph we have the lowered activation energy. Delta G is very less in enzyme catalyzed reaction, but it is more in case of uncatalyzed reaction, less in case of enzyme catalyzed reaction. And what is this activation energy? It is the minimum amount of energy which is required to start a chemical reaction. So that means if we want a reaction to occur very fast, there should be a presence of enzymes, because enzymes will lower the activation energy and they will speed up the reaction. Thank you so much for listening here.